What's that?
Repeat what you're doing.
Oh, what am I doing now? Oh, sorry. Well, I'm trying to actually show you something if it works of the Snapdragon 805. Okay, so here is another demo that I'll show you first. This is a demo of so this is actually 1080p video, and you can see here 1080p video on Snapdragon 800, which is actually the older generation processor. This upsampled to 4K. This is a 4K TV, and I'm just connecting to the 4K TV on HDMI. And here it's upsampled using the HQV technology that I'm talking about. So you see here the difference. This is what it looked like if you didn't do any post-processing. This is what it looked like if you did some post-processing. So you can see the noise cleaned up, and you can see the details come out much brighter. And so if you just take 1080p video and you watch it on a 4K tablet, this is what we're going to make it look like. So the content is still 1080p. So there's no real high resolution content. We're just upsampling it, cleaning up the noise, zooming, all the stuff that I showed you. This is something that you'll have in your next generation part. So this actually here shows you clearly. So if you see the edges and if you see the lines, we clean it up. So you can see all the noise here that's flickering here, and you can see we clean it up here. Okay, so that's one. Okay, so I'm going to show you a little bit of the graphics demos. This is actually a demonstration of what we call the swimmer. This is something that's done actually by my team. I have a small graphics studio. And what we do in the studio is that we actually develop some content. And we give out this content to the game developers so they can actually use it. Here what we did is we said, what would it look like if you use Snapdragon 405 with the Adreno 520, Adreno 405 with the Snapdragon 805 with Adreno 420 in it. And you can see here what the quality is like, and I can pause it here, and you can play it. And actually here you'll see what happens here is that you can see as I change the lighting. So you can see that I'm actually moving the lighting to the side, and you can see the quality of the skin tone, quality of the resolution. It signs out the shadows. This is what I mean. There's a lot of technology that goes into making this look like this, and you can move it around. And the next generation games you'll see will be like this quality. And this is on a phone, by the way, and it runs on a battery. Okay, so I'll show you something else. Yeah, I wanted to show you guys this one. So it'll take a few seconds to load, so let me explain this to you. So this is actually the game engine. This is the game engine by Epic Games, which is called Unreal Engine. This is Unreal 4, which is their latest engine. And this was the first time on Android. We haven't seen anybody port Unreal to Android. This actually is not quite optimized. We got it running, and it's running at a 2500 screen. And I'm just pumping it out to HDMI. So it's actually, the TV is upsampling it to 4K. So you'll see some jagginess because it's a TV upsampling. But still, I want you to get a feel for, I'll run it in a guided tour. I want you to get a feel for what it looks like. So this is a tech demo that they built to show what you can do on the engine. But basically, they make available all these art assets. So when you build a game, you can use these assets to build. So notice the lighting, notice the shadows, notice the realism, notice things like water. Those are all like effects. So if you want to build a game with water, you just call the water technology here, and you'll get it. And you can see how it goes from very bright to very dark, and you see as the light moves, you see the reflections of it. And that's what you're going to see on a phone, and that's actually the amazing part of it. So if you're playing a game like this and someone walked into the room, they'd think you're playing on an Xbox or a PS3 or a PS4. And as you can see, it looks a lot more realistic and stunning here because the TV upsampling is messing it up a little bit. But you can see on the screen, it looks a whole lot cleaner here. You see some aliasing and stuff there, but maybe upsampling. Okay, so that's that. Those are some of the technologies on gaming, and I want to show you if I can get my visualizer up. For some reason, it doesn't like me. I promised you'd like me a little bit before. Well, okay, so maybe while I wait for that, I'll just show you guys some video. It's probably just as good. 4K videos. So what does a 4K video look like? So this is actually a 4K video that that we are playing here and displaying it, and you can see this is actually full performance. This is full performance 4K running on the Snapdragon, and you can see the details, see the quality using HEVC. This is probably like 20 megabits per second.
70 was written.
What's that?
70 megabytes.
70 megabytes, yeah.
Yeah, it was written in the title.
Yeah, but I don't know how many bits per second it is. It's maybe the size of the file.
Okay.
I think it's roughly 20 to 30 megabits per second is what we run. So you can see the sort of difference with HQE and without HQE of the same 4K content. And what I want to show you here next is actually kind of interesting. Let's see if I can get it up. Yeah, dual display. So this is kind of interesting. So here what I'm doing is I've got a 2K display, which is a 2K UI, on this. So but what it's doing is it's actually going from here to here, so it's same on both sides. So I'm going to switch to 4K UI, and what that does is so the UI there is 4K, and here it's 2.5K. So I'm running two screens at the same time. I'm running a 4K there and a 2.5K here, and you can actually see that I can move this around, I can do what I want, and it'll show you. So, and I can play one of these videos, and the UI here remains the same, but it's actually going to play the video there. Now this takes the tremendous amount of performance, and I'm able to run 4K on the other side. And why is this important? This is important because let's imagine you have a 2.5K tablet, and you recorded some 4K video, and you're sitting in your house, and you want to do something, and then you have a 4K TV, and you can say, you know what, I want to watch this, and it blasts it to 4K on the TV while you're still doing what you need here. So now I'm running 4K on the 4K TV, and I'm running 2.5K on your screen, and you can probably run a game, or you can do UI, or whatever you want here, and it'll still run the same thing there. So you can see I'm able to run the browser UI here, and what's going on, and I can switch and say, okay, I have to show you here, this is about 28.9 megabits per second, and I can switch to a different one, and you can see the quality. Now, this is seriously impressive in terms of performance, because now I'm able to handle, I don't think there's any processor on the planet that can do this now, that I can run a 4K UI and 4K on the other side on HEVC, hardware decode, while I manage your phone fully. Okay, so I'm going to pause there. I think there's lots of other demos that I can show you later, but at least you get a feel for what it is. There's one other thing I want to show you, which is probably this one. Let's show you that. So here's another problem. Many times what happens is, you take a picture, and you don't know whether you want to keep the background in focus or the foreground in focus. And you take a picture later on, you're like, I wish I had the background out of focus and the foreground in focus. So what we do here is we got this technology called UV focus, which is actually launched, by the way, in the new LG phone. You take the phone and you take the picture. When it's taking the picture, it just shoots multiple pictures at once. Then it fuses those pictures, and later on you can decide what you want. Like, for example, here you can say, I want this to be in focus and everything else to be out of focus, and it'll actually do that. Or you can say, you know what, I really want the background to be in focus because the foreground is not that interesting. Or you can say, I want all to be in focus, and it gets everything in focus. Now this is done all on Snapdragon just by taking a picture, right? And you can take multiple shots at that. And tomorrow when you're watching tennis, you'll wish you had that. I'll show you one other demo and then we'll wrap up. Here's actually something called, this is pretty good. Something called Chroma Flash. The problem with Chroma Flash is this. Typically when you take a picture, let's say you shoot without flash, it kind of looks like that. It's got a lot of noisy and it lit. But if you actually shoot with flash, it looks like that. The face looks great. Now you wish you wish you had a combination of both. You really wish that. So what you can do is we can actually fuse them. And what the Snapdragon does is you actually don't know this. You pick up the camera and shoot. It shoots really quickly, one without flash, one with flash. And then it combines them, and now you get the background cleaned up and the foreground in front. So we just shoot so fast that you'll never see the difference. That's actually something that also you'll find in the Snapdragon technologies. The other one is OptiZoom. So this is the other problem. So many times you find that I want to take a picture of something, but I wish I had more resolution. I wish I could zoom to it more. The problem with that is you can shoot, but you don't get enough. So if you shoot multiple pictures, we can combine them, like take rapid sensor pictures, and then we can fuse them. Then what we can do is we can actually make one much higher resolution image. So you can see now if I zoom, see the data, see everything looks much clearer, much better, instead of just taking one picture at a time. This is also something you'll find. So the whole concept is, as I was telling before, when you have a gigapixel ISP, you can shoot so many pictures so fast, and you can combine them to do different things. Okay, so I'm going to stop there, and I'll show you some of the demos later, but I